Alright, so here we go. Let's talk about this. Now, from your videos from last time, what did you guys get for the formula of triangles?
Half base times height.
1/2 base times the height. Very good. Okay, so the area formula for a triangle is 1/2 the base times the height. So when we look at the triangles, typically our base, honestly, it doesn't even matter which side is the base. The thing that matters is that whatever base you choose, the height must be perpendicular to the base. So you might want to make a special note of that. The height has to be perpendicular to the base. So in a very simple model, if I use this bottom line as my base, the height is the segment from the opposite vertex that is perpendicular to this base.
Wait, the height has to be perpendicular to what?
To the base. So whatever side you choose to be the base, your height must be perpendicular to that. And that's going to work for all the shapes that we're going to be talking about over today and tomorrow. Now, from the video, we're just going to kind of repeat ourselves here. From the video, we talked about you have 3 outcomes for the height, depending on different types of triangles. I think most of you guys are accustomed to what we've shown you here, where the height is inside the triangle. So that shouldn't be a surprise to anybody that our height is inside the triangle. Sometimes the height can actually be on the triangle. So in a right triangle, your height is actually sitting on the triangle. Well, what do you do with that last one? Connor?
Outside.
Yeah, your height's actually going to be outside the triangle. And you got to think about it, taking BC, we're going to extend the base. And so our height is actually this distance outside the triangle. If you want to think about it as a physical existence, the height is literally, imagine you being at the top of the triangle and dropping a plumb line and letting it go until it hits the floor. Okay? It's a weighted, it's a line with a weight on it. And they call it plumb because it's always going to be perpendicular due to the force of gravity. So when we look at this last triangle here, if you're all the way up here at A, and you're going to drop a string, it's not going to go slanting in toward BC. Where's it going to go? Straight down. So the same concept here. Every single time, that line is going to go straight down. Now, guys, I'm going to be very disappointed in you if you can't tell me the area formula for a rectangle. Length times width.
Base times width.
Base times height. It's the same concept, guys. It's a shoebox problem. Come on. You've been doing this since the 3rd grade. When you guys first learned to multiply, one of the first things you learned to do after that was find the area of a rectangle.
I did not learn that. Oh, yeah.
So the area of a rectangle is base times height. Please keep in mind that squares are rectangles.
Rectangles and squares.
No, rectangles are not squares. So therefore the area of a square is still base times height. Or just side squared.
Tell us that basically triangles and rectangles that now. That's how you get that half.
Nope. But if you want to think of it that way, it's fine. Technically, a triangle is a parallelogram cut in half. Now, in a parallelogram, the formula, Sebastian,
Yes.
is what? Base times height.
Yes.
But, to be slightly different, notice in a rectangle, how is the base versus the height?
On it.
It's on it. But when you go to a parallelogram, your height is not that slanted edge anymore. Well, it depends. Guys, stop the talking. It could be outside. Usually, though, Bree.
It'll be inside, but it's the same as it is on the inside.
Exactly. So we usually write it on the inside. Now, one of the first problems you're going to see in your homework tonight looks kind of crazy, doesn't it? Okay? Well, let me ask you this. Let me unlock this baby here. Let me bring this out here. That's our base and a height, correct?
Yeah.
Okay, guys, if I take this parallelogram and I spin it, did my area change?
Yes.
But what did change? The base and the height changed. So now I have a new base, and I have a new height. But the area stayed the same. So therefore, my original base times the height is equal to my new base times my new height. And that's how you'll solve the first problem on your homework. And keeping in mind that just because you spun the parallelogram does not change its area. The way you find the area will change, so those numbers will change, but not the area itself. And if you need to, you might want to spin the laptop. Did it help, Taya? Oh, sorry.
Not at all.
Spin your head. Oh. All right, here we go.
I want to see this. Spin your head, Mr. Clemens.
No.
You funny. He does.
Failure number 1. We have a triangle with a 4-inch base and a height of 4 inches. How do you find the area of a triangle? Base times height. Divided by 2. The area of a triangle, you gotta make sure you use the right shape. So the area of a triangle is 1/2 base times its height. So 1/2 of 4 inches times 4 inches is, well, I guess here we go. What's one?
8.
4.
8
what?
inches.
Squared.
Squared.
Guys, area units are squared units.
4 times 4 is 16.
Okay. Guys, what's x times x?
Is x squared.
What's z times z?
X squared.
What's n times n?
N squared.
Second power.
So what's inches times inches?
N squared.
Inches squared.
Squared.
That's why your area units are always squared units. If we are finding volume, length times width times height, right?
Yeah.
So what's inches times inches times inches?
Inches cubed.
Inches cubed.
Inches cubed. So your volume's cubed, area is squared. All right, Taya, number 2 is similar to what you have going on in your homework.
Value of 8.
Okay. Find the value of h. Does the area of this parallelogram change if I change my perspective? If I rotate, does it change the area? No. So what is my area in its given format? What's one way to find the area?
7 times
8
10.
equals 8 squared.
10 times 7. I'm going to go with Connor on this one. Okay, Bree, I'll come back to you in just a minute. 10 times 7, which is 70. That's because my base is 10, and the height relative to that base is 7, correct? All right, now, if I rotate this, and it is a parallelogram, if this is 8 up here,
Then that has to be
what's down here?
8.
That's 8. And now I have my height perpendicular to the base. So now my area can also be represented as 8 times h. But the area doesn't change, does it?
No.
So therefore, 8h equals 70. Does that give you a better picture of what we're doing there, Taya? It's really hard to see in that image. I agree with you on that first problem of the homework. Really hard to see it. But you got to pick it up, spin it, get some grasp of that. Okay? But that's the major concept. That you can find the area in 2 different ways, and that's how you can solve for the h. Therefore, h is 35 fourths.
That's ugly.
Yeah.
Mr. Connor.
Is that 70 over 8 reduced?
Yes.
Oh,
So go to the bathroom.
In a minute. We don't know.
Don't change it yet.
Okay.
Okay.
Why is your like in the corner? Why is it
This way that it comes out. This is on the diagonal. That's the other. All right, guys. The last thing I want to go over here, which is a very, very useful tool, and that is finding the area of the shaded region. Okay. And Shay, I guarantee you, if you're working on that house, I guarantee you're doing this. You might not. I guarantee you are. But you're probably not aware of how you're doing it, but it's built into that. It's somewhere within that curriculum. I know you guys have done this before. So to find the area of the shaded region, keep it simple, guys. Take a look at the number 4. How would you, if I asked you, okay, let's say that's the floor plan of the kitchen. And I've got this table over here, and I've got this table over here, and I need to know what's the square footage of space that I need to tile. How would you do that? Keep it simple. Thea? Okay, on the whole, okay.
And then you find the area of the 2 smaller ones, and then you add those together and subtract it from the big one.
Bingo. Guys, the big idea out of today, take the area of the whole and subtract the area of the unshaded, and that will give you the area of the shaded region.
Whoa. Mine.
Okay? I know. It's amazing. Okay? But what happens is within this, you get really crazy outcomes. In fact, I'm going to give you a preview for the problem set you guys are going to get tomorrow. If I gave you a rectangle that had quarter circle here, quarter circle there, and then I said, okay, find the area of this region. What would you have to do?
Find the base first.
Skip it.
Take the area of the whole and subtract out the unshaded regions. And if I have a quarter of a circle and another quarter of a circle, I have
Half
a circle. And we're done. It's a really simple problem. So this is actually the major concept here. Now, on number 3, it's actually a lot easier just to find the area of the shaded triangle rather than doing the whole thing. Because remember how you find the area of a triangle?
Okay, so
Area of the triangle is 1/2 base times the height.
yeah,
What is the base of our shaded region?
4.
What's the height of the shaded region?
8.
So it's half of 4 times half of 8. So we've already done that. So which gives us 16 units. Hard stop. Okay. And we've already talked about how to do number 4. I'm going to assume that you guys know how to find the area of a rectangle and subtract out other rectangles from that. Did you guys get the concept to find the area of the shaded region? Okay. Do you really need that to be in the recording?